All right. Hello, Science 10 students. Here we are, bright and early Sunday morning. There we go. Bright and early Sunday morning? No, it's Monday morning. It should be. Anyways, I got to choose my pen. Hadn't set up my pen properly. Get the right thickness. Here we go. Hello, and welcome from Science Central. Today we're talking about kinetic energy. We've been talking about work. Work was equal to force times the distance that was traveled. We've talked about potential energy, gravitational potential energy. There are other forms of potential energy. And so we talked about EP being mgh. So this is as we take an object and we move it upwards, it gains potential energy. It has the potential to do something, to do work. And so these are the two things that we've done so far. Today we're adding to this story with kinetic energy. Now, kinetic energy is the energy of motion. Kinetic, we can take a look at this first part, and it comes from a Greek word, kinema, kinema. And I was writing that with a C because that's where we get our word cinema. And you go to a cinema for moving pictures. Now, when you go to a movie or when you're watching animations and so on the screen, what you're seeing is things aren't really moving. What they're showing you is a series of rapid images. They're showing you those images very, very rapidly. So the object's here, the object's here, the object's here, the object's here. And then they show each image is a little bit different. So we get the idea like this is like a ball bouncing. So we have this moving image. One of the first moving pictures showed a train coming into a station. And people would freak out because they'd never seen anything like this, and they thought the train was going to crash into them. Anyways, so kinema, cinema, moving pictures, motion. This is the key thing, is that we have an object that is moving. So the symbol, the formula that we use for this, the symbol that we use for this is EK. And the formula we have for this is going to look complicated. It's not too bad. It has the number 1/2 in there. It has related to the mass. And then we talk about V, the velocity. But the velocity is going to be squared. So EK is the kinetic energy. What do we measure energy in? The answer to that is joules. More Newton meters, but when we're talking energy, we're talking joules. And so, yeah, here again, we're going to have potential energy was in joules and kinetic energy is in joules. We have the 1/2, which is what we call a constant. It's a numerical value. It's there to make the numbers come out right. And we have our m, which is our mass, and our mass has to be in kilograms. And then we have v, which is our velocity, our speed, and that's going to be in meters per second. Okay, so this is the format. So we can calculate EK and 1/2 mv squared, or we could talk about the mass, and the mass is going to be our EK over our v squared, and we're also going to have our 1/2 down here. Or we can talk about velocity. Hold on, we've got that squared thing in there. So we're going to have the square root. The square root, well, the square root of our EK. And again, we're going to have our 1/2 down here, and we'll have our mass. So 3 variables that we have in here, 3 relationships, and this is how we can talk about them, how we can calculate them. It is algebra that takes us from one to the next. And don't be afraid of this. Don't be afraid of this. Have these written out beside you. And as you're going through questions and going through the worksheet that should be posted here along with this, have these written out and use them. That's the whole purpose. How much energy does a 3 kilogram block have moving at 1.2 meters per second? So what Again, we go through this, we take a look at information. We have 3 kilograms. It's a number. Well, what is that? Well, that's a mass. Then we have this 1.2 meters per second. Well, that's our velocity. What are we trying to find? The energy, our K, EK. So our kinetic energy, EK, is equal to 1/2 mv squared. So we're going to go 1/2. And then our m, which is 3 kilograms, so 3.0. And then we'll have our 1.2 meters per second, but we square this. So how do we do this? I'm going to go 1.2, and I'm going to square it. So that's equal to 1/2 times our 3.0. Okay, I'll leave that like that. And then we have 1.44. That's the square of here. And then I can go that times 3, and then times 0.5. And then we get is 2.16 joules. I did this slowly just so you wouldn't get lost in terms of doing the calculations. I don't want to assume you're going to have difficulties with this because I don't think you really should. Yet at the same time, I don't want to assume that you're not going to have difficulties with this because it's new. You haven't, up until now, math is in math. Science is lots of words and different things like that and concepts. Well, now what we're doing is that we're using math in order to calculate some of these things. I often talk that math is the language of science. It's how we communicate. So don't be afraid of it. And like here we, all right. So next year, there's bio, there's chem, and there's physics. Now, I guess are they doing biosocials again? I don't know. Strange combination, but anyways, generally bio's not bad. Generally bio is pretty straightforward because bio you're studying about things that grow, and you're about us as people, living organisms and so on. So biology is interesting. Not a lot of math. Math comes in when you go to college. When you're in university, then you're going to get some math coming into biology. Chemistry, we're mixing chemicals and we've got our beakers and test tubes and so on. Oh, an explosion, blah, 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 blah. Well, really, there's a lot of math in chemistry, and that can cause some people some difficulties. Don't want to scare you away from it, but just recognize that that's, chemistry deals with some math. Physics has lots of math. We have a lot of equations that we use, and so sometimes people really get turned off because there's all this math that they have to do. A lot of people don't like math in high school. Math, you got to think and stuff like that. And here you're using it in physics. Just recognize these things here. So sometimes this is thought of as being the hardest, and biology as being the easiest. And the issue here is the amount of math that comes into this. And chemistry sort of comes in down here, I would say. Anyways, just to let you know. How fast is a 2.1 kilogram block moving if it has 230, excuse me, joules of kinetic energy? All right, so our number is 2.1. 2.1 kilograms. Well, what's that? That's our mass. And we have this 230 joules. What's that? Well, that's our kinetic energy. What are we being asked to find? How fast? Our velocity. That is what we're trying to find. So velocity is equal to the square root of our kinetic energy over 1/2 times our mass. That's it. Easy peasy, lemon squeezy. Velocity. So we're going to take our kinetic energy, 230. We're going to have our 1/2 times our 2.1. All right, so let's do the bottom first. So we're going to go 0.5 times our 2.1. So that we'll have 230. 1/2 of 2.1 is equal to 1.05. And then we have to do the square root of that. So I'm going to go 230 divided by 1.05. So that's equal to the square root of 219. So do my square root button. There we go. And so what we get is 14.8. Well, what are we finding? Well, we're trying to find the velocity. What are the units of velocity? Meters per second. Traveling at 14.8 meters per second, we'll have 230 joules of kinetic energy. All right. What is the mass of a ball with 460 joules of kinetic energy moving at 1.3? All right, let's see. What information? We have 460 joules. What's 460 joules? Joules is energy. This is kinetic energy, so this will be an EK is equal to 460 joules. 1.3. 1.3 what? Meters per second. Well, what do we measure in meters per second? Our velocity is in meters per second. So what are we being asked to find? What is the mass? Oh, mass. That's what we're trying to find. All right, so our mass, well, we're going to have our EK, and we're going to divide that by our 1/2 and our V squared. That's in our equation. It's 2-3 pages back. Let's substitute in, we know, 460 joules divided by 1/2, and we'll have our 1.3. Don't forget, you've got to square it. Okay, so I'm going to go 1.3 squared. So I'm going to get 460 joules on top. I'm going to get my 1/2. 1.3 squared is 1.69 times 0.5, 1/2. So I'm going to get 460 joules divided by 0.845. You should really follow along and make sure I'm doing this right. So our math. I'm going to go 460 divided by my 0.845. And I get a value of 544.3786982, 544 kilograms. That's a pretty big mass. You're talking a small car, motorcycle, 1.3 meters per second, not moving that fast, but it does have kinetic energy. All right, let's go back. Oh, right, this is a good one. What happens to the kinetic energy if the velocity is doubled? We're driving a car. So let's say we're driving a car and the velocity is equal to 50 kilometers per hour, kmh, or 100 kmh. Now, we can change 50 into meters per second, and that's equal to 13.9 meters per second. And 100 as meters per second is 27.8 meters per second. So these are the two velocities we want to deal with. 50 kilometers per hour, so that's city or town driving. 100 kilometers per hour, that's highway. Okay? So how do we calculate kinetic? What happens to the kinetic energy if the velocity is doubled, right? Well, our EK is equal to 1/2 mv squared. Okay. What's our m? What's the mass of our car? I'm going to say right now it doesn't really matter. Okay, so let's use a mass of 1. It's a very small car. So we're going to have 1/2 times 1 times my 13.9 squared. Likewise, over here, we're going to have 1/2 times 1 times my 27.8 squared. This is a doubling of the velocity. All right, so let's calculate 13.9 squared times 1 divided by 2. And that's equal to 96.6 joules. This number, the value of the number doesn't really matter. Let's calculate this one over here. 27.8 squared times 1 divided by 2 equals 386.4 joules. 96, 386. Well, here's the thing I want you to recognize. Speed doubled. That's what it's supposed to say. Speed doubled. If I take my 386.4 and divide that by my 96.6, that's equal to 4. Double the speed, 4 times the energy. So what does that mean? 4 times the energy. 4 times the gasoline. If you're driving 100 kilometers per hour, driving the same distance at 50 kilometers per hour, 100 kilometers per hour, you should be using pretty much 4 times the amount of gasoline that you'd be than driving slow. Driving fast uses up more energy. 4 times the energy to lose. When stopping. So what does that mean? Well, 4 times longer. So somebody jumps out in front of you, it's going to take you 4 times as long to bring the car to a stop because you've doubled the velocity. Or if you run into a tree, there's 4 times the amount of energy to get rid of. So 4 times the amount of energy braking the car and you. When you double the velocity, you quadruple the amount of energy. And this is where they say speed kills. Well, it's not the speed that kills, it's coming to a stop that kills. And the faster you come to a stop, the more you're going to hurt yourself. You run into a tree when you're traveling at 5 kilometers per hour, you could set off your airbags probably in your car. You could cause some damage, but you're not going to die. You crash into a tree when you're going 100 kilometers per hour, you could die. Anyways, on that morbid note, the point is that when we're talking about kinetic energy and if we're talking about cars, there are some things that we can understand happens with this energy and so on. All right, spoken long enough. As I say, there's a worksheet. You'll have, let's go 2 days again, so that's Monday and Tuesday, and to be working on it. If you're having questions, please contact me. More than willing to try and help you. Recognize I'm at the school starting this week. They're not really having students coming in June 1st. Students are coming back, but we're talking sort of like 20% for grades 10, 11, and 12, and so on. So that's sort of like 1 day a week. And I'm not sure, well, details will be coming out in terms of what that's going to look like. It's not regular classes, it's really tutorial time. And if you're having some questions and difficulties, you can come in, get some answers, you can spend some time going over things. More than willing to help you out on that. But as I say, you can be contacting me through the week and things will be good. Now, did I go through? Oh, yeah, I did that. All right. Talk to you later. I'm going to stop this.